Hey guys, welcome to 11.1 tutorial where we're going to be talking about gas laws. And really to intro into our talk about gas laws, we're going to be talking about converting units or unit conversions. There's a lot of units that we're going to be introduced here in this video, and so I'm breaking the units down into different types of units. The first types of units we're going to be talking about are units of pressure. Pressure is basically what pressure is the amount of force exerted by gas particles. Well, let me say we're specifically talking about pressure in terms of gas particles because we're studying gases. So the pressure, when we're talking about, we'll be learning about three different types of pressure, or three really different types of units that can stand for pressure. And the first we're going to learn about is ATMs. ATM stands for atmospheres. We normally live under 1 atmosphere or 1 ATM. That's like the regular room temperature, not room temperature, but room pressure would be 1 atmosphere, okay? MMHG stands for millimeters of mercury, because HG stands for mercury. And then the last unit we're going to talk about are kilopascals. Pascal was a scientist, and so this particular unit's named after him. And what I've shown here is I've shown you the conversions between ATMs, millimeters of mercury, and kilopascals. Millimeters of mercury are also known as torr, T-O-R-R, which is another name of a scientist. So let's talk about how we can convert between these different units. Well, if I give you any unit, let's say I gave you 57 kilopascals, kPa, okay? Whatever unit they give you, if you're supposed to convert to a separate unit, if you're supposed to convert to like ATMs or millimeters of mercury, you always put your given unit over 1, and we're going to set this up just like a dimensional analysis problem. Since we have our given over 1, we see the unit that we're given is kilopascals, so we're going to put that on the bottom to cancel out. And then the unit that we want to go to, we're going to put on the top. So let's say we're in kilopascals, okay? But maybe we don't want to be in kilopascals. Maybe we want to go to ATMs. Then we would put ATM on the top, and then I would put my conversion numbers in these spots. So kilopascals, you're always going to put 101.3. That number will always go next to kilopascals. And then 1 will always go next to ATMs. So essentially, if I want to go from kilopascals to ATMs, I'm basically just dividing by 101.3. In this example, I'm given millimeters of mercury. We're given 790 millimeters of mercury, and we want to go to kilopascals. So you always put your given over 1, okay? And then we're going to set up our conversion. Unit conversions are always going to be a one-step problem. You always will just need one fraction. So since we have our given unit at the top, we also want that at the bottom. So I'm going to put millimeters of mercury in the bottom. And then we are, in this particular example that I'm making up, we're going to go to kilopascals. So that means whatever unit you're going to goes on the top, okay? So whatever unit you're going to goes on the top. And this is always the given unit. So we were given millimeters of mercury, so we put that at the bottom so they can cancel. So now I just kind of plug my numbers in. Remember how I told you 101.3 will always go next to kilopascals? So I do that number next to my kilopascal unit. And then 760 will always go next to millimeters of mercury. So to get from millimeters of mercury to kilopascals, I'm going to be multiplying by 101.3, and then I'll be dividing by 760, and then I'll get kilopascals. Now let's talk about volume. Volume will always be given to you in liters. It could be given to you in milliliters or liters, but the unit we always want to go to will be liters. Unlike pressure. Pressure you can either be in ATMs, millimeters of mercury, or kilopascals. In volume, we pretty much always want to be in liters. So if I give you something that's not liters, like milliliters, we are going to convert, and you may have your own way of figuring out how to get to liters by moving your decimal or dividing or whatever it is you do, and if that makes sense to you, you can stick with your method, but this is the dimensional analysis way to get to liters. We have milliliters on the top, and so to convert out of that, we're going to have to put milliliters on the bottom, and then remember what we're going to always goes on the top, so if we want to go to liters, that unit would be on the top. And then now we just plug in our numbers. 1, you can see, is always next to the liter, so I put 1 here. And then 1,000 is always next to milliliters, so I'll put 1,000 on the bottom. So to convert from milliliters to liters, I'm essentially just dividing whatever number I'm given in milliliters by 1,000. So for this example, I would be 0.350 liters. And now we're going to talk about units of temperature. You're probably more used to temperature being in Fahrenheit, but that's not what we use in the science field. We use degrees Celsius, and we use Kelvin. Kelvin actually doesn't have degrees. It's kind of weird. We just say Kelvin. So, for example, in this problem, you would say 0 degrees Celsius, but when you talked about the 273, you would just say 273 Kelvin. You wouldn't say degrees Kelvin. Kelvin, again, you can probably guess, was named after a scientist or egotistical, what can I say? So if in pressure, remember how I said any unit is fine, ATMs, millimeters of mercury, kilopascals, doesn't matter. Volume, I said, has to be liters. Well, temperature always has to be in Kelvin. So I'm going to put this on here, convert to Kelvin. Just for reasons, we just like it to be in Kelvin. So the way you do that is you just add. If you're in degrees Celsius and you want to go to Kelvin, you just add 273 and then you're in Kelvin. If you're in Kelvin and for some random reason you want to go to Celsius, you would just subtract 273 to get Celsius. So for example, let's say we had 25 degrees Celsius and we wanted to find how much Kelvin that was. We would just add, we would do 25 degrees Celsius plus 273, and then we would get 528 Kelvin when we added them together. And again, if I want to go the opposite way, let's say that I had 528 Kelvin and I want to go to Celsius, you would just subtract that same number and then you would end up with degrees Celsius. So adding goes to Kelvin, subtracting goes to Celsius. The last conversion we're going to talk about is actually it's a law. It's called Avogadro's law, and you may remember, or hopefully you remember Avogadro. Avogadro was the guy who came up with the number of the mole. Came up with 6.02 times 10 to the 23rd particles or atoms or molecules will always equal a mole. Well, he also discovered that if you had a gas under ideal conditions, if you had exactly 1 mole of that gas, it would take up 22.4 liters of space. So this conversion is called Avogadro's law, which states that if you have a mole of gas, it will always equal 22.4 liters. So the problems that we're going to be doing are similar to maybe some of the stoichiometry problems that you've done in the past, but they're a lot shorter. So one thing I could do is I could give you liters and I could ask for moles. And then I can also do the opposite. So I could give you moles and I could ask for liters and you'd have to convert. So let's say I gave you 0.52 moles of ammonium, which is NH4 over 1. This is a gas, and I wanted to find out how many liters that would take up. I would put moles of my given on the bottom, because remember, you always want to cancel out of that, so we're going to put that on the bottom. So that's canceled. And then what do we put on the top? Okay, so remember how I always said you always want your not your given. What am I talking about? You want what you're going to be on the top. So liters of ammonia needs to go on top. And so what number do we always put next to mole? It's always 1. What number do we always put next to liters? It's 22.4. So in order to go from moles to liters, I'm going to be multiplying by 22.4 to get my liters. And the last thing I just want to mention before we are done is something called STP. You're going to see this a lot in our unit. STP just means standard temperature and pressure. Standard temperature and pressure are just the temperature and the pressure of a normal average conditions, okay? And so 1 ATM is standard pressure. That's the normal pressure under normal conditions. 273 degrees, I keep saying degrees, 273 Kelvin is your standard temperature. Also, that would be 0 degrees Celsius, okay? That's your standard temperature, and 1 ATM is your standard pressure. So anytime it says standard temperature and pressure, it's talking about 0 degrees Celsius, or 273 K, and 1 ATM. And that is it for this video on 11.1. You can begin your online challenge, which will have you practice a lot of these conversions. Good luck.